Hi everyone and welcome to our fourth webinar in the series. Now last month we heard from Jürgenstein, a product specialist, all about farm layout and infrastructure. Now today's webinar follows on nicely from what he's been discussing, so I'll be referencing and referring you back to his webinar quite frequently. Now if you've missed any of the previous webinars listed above, please be sure to go check them out. So I'm Briar, and alongside my colleague Innocent, we will be taking you through this pasture management and AMS farming webinar. Now we are both farm management advisors for Oceania, and we provide management solutions for our farmers and helps working with them to set goals and working to achieve these. So the objective of today's webinar is to take you all through the pasture management and automatic milking system and how it compares, but how it may also differ from a conventional system. It's all about sharing the basics of what we do to help our farmers throughout the whole process of transition through startup and to the ongoing support we provide. Here at Lely, we understand every farm and farming setup is different, and that is why we do our best to come up with a strategy for every individual farm. Now, some of the main points we will be discussing include the influencing factors and foundations of pasture management, pasture allocation and why it's important, grassland management, some top tips around that, and then we'll be discussing some grazing strategies, which includes all about ABC grazing principle, which Jürgen discussed on last month. We'll then look into cow movements and moving into the top tips when grazing with robots. Then I will be handing over to Innocent, who will be discussing the pasture growth curve. He will then summarise the webinar and provide you details if you've got any questions. So let's get started. Influencing factors. So every farm is different, whether it is conventional or automated. So there are many different things to be taken into consideration for the initial split up of a farm or simply for the day-to-day operations. Firstly, you've got the farmer's goals. Every farmer is different in what they want to achieve, whether it's pasture related or milk production related. Breeds of cows influence the decisions we make. Even though we work with many different breeds at Lely, it is important to take into consideration the requirements of being met in all aspects of milking, feeding and health when making management decisions. Pasture allocation includes the pasture available, the size of the paddocks, but again, also what's the requirements of the cow at their particular stage in lactation. Then we move into the roadways or the raceways. What conditions are these in? Do they need improving? Do they need splitting up? These are important to reduce lameness on farm. But we also need to take into consideration the distance a cow will be travelling. And then we move into the water points. Where can the cow access water? Is it just in the paddocks? Is there going to be water in the sheds? Or even along the raceways? However, things such as the weather can also influence the decisions that we make around the climate that the farm is based. Alongside the influencing factors, a solid foundation ensures for good cow flow. So foundations of pasture management include things such as the initial farm layout and structure, which we heard a lot about last month. And then you move into other things such as the feeding goals. What is the farm's goals around feeding? Is it solely grazing? Is there an indoors area? What supplement feed is going to be brought onto farm or grown on farm, such as maize, your hay, your silage, but also the concentrate and what concentrate will be fed through the robot and at what level. This is where we like to work alongside a feed advisor or a nutritionist to ensure that the cows and farmers are getting the best they can. Good farm management helps us indicate Good farm management helps us understand cows and what they're saying to us. For example, their manure. The manure colour and consistency can say something about their protein and energy balance. For example, if we're taking into consideration milk urea levels, low milk urea in combination with a light manure colour indicates a protein shortage. High milk urea, a light coloured manure, indicates poor feed conversion efficiency. Alongside the consistency, if it's too thick or too runny. The cows wear a rumination tag which shows the farmer the rumination. So low rumination could indicate too little fibre or structure in the ration. On the other end, excessive rumination could indicate that fibre levels are too high. And lastly, we move on to free cow traffic and the cow motivation. So free cow traffic. This is based off the 6 basic elements: space, feed, water, light, air, and rest. So with Lely's principles, the cows are free to eat, rest, drink, and be milked when she wants with no pressure. It's all about the natural behaviour of the cow. This free cow traffic principle extends to grazing management. However, in a grazing-based system, the motivation is access to fresh grass. Cows have the freedom to move and look for fresh grass. Therefore, correct pasture allocation is important, and I will touch on that next. Then we move into the nutritional requirements of the cow in the different lactation stages, ensuring the adequate balance of protein, energy, and fibre, and making sure they're getting that from the grass, or supplement feed, or the concentrates fed. The other important thing for free cow flow traffic is the training of the cows, start up or at the start of lactation. It's important to get them into a routine and provide them with a positive experience. Ensuring adequate laneways which are in good condition, the correct positioning of a grazeway so that cows aren't having to do a 90-degree turn and lower ranking cows being bullied. But also the water access. These factors all influence how a cow moves throughout the system. Other factors such as the climate and the weather, grass quality, variety, palatability all play a role within the cow movement. So the key benefits of the free cow traffic principle, it's all about the cow and improved animal well-being. So there's less pressure on the cow, so there's less lameness. There's less stress for the lower ranked cows, which means happier, healthier cows which produce more milk. Now, pasture allocation. So within the AMS system, pasture allocation is key to helping cows with cow movement. You've got the under allocation of pasture, which cows will move quicker, resulting in more energy required by the cow as they seek fresh grass. Then we move into the other side of over allocation. Cows will become lazy and require more labour from the farmer to collect the cows from the paddock. And then you've also got the result in poor utilisation of pasture and poor future water quality. Therefore, pasture allocation is key as cows need to be motivated to visit the robot and access fresh pasture. Grassland management. Various grazing strategies can be adopted, but the best option will vary from farm to farm and depends on many factors. What is your own situation and ambitions? What is the walking distance and soil type? Topography and social issues are also important to consider. So operating a back fence when required to increase regrowth, maximum 3 days per paddock of the same paddock, doing farm walks to help establish a rotation length, but also for pasture quantity and quality to consider a reseeding program. Grazing options. Now, Eugenstein offers a very nice background on AB and ABC grazing and explains how the ABC system is superior and how it affects cow flow. So if you've not watched this webinar, then be sure to go check it out after this. So in basics, AB provides a 12-hour grazing period, ABC an 8-hour period, and ABCD a 6-hour period in each block. Now, some people also incorporate an indoors area into this for various weather reasons. Now, we know that the ABC and ABCD system is superior, as this benefits the heifers and the lower ranked cows, as they're not getting pressured as much. It encourages cow movements, as the gate change every 6 to 8 hours. More incentive for cows to move. However, you've also got the fact that not every cow will visit the ABC or D area, meaning there's less pressure on the pasture and better pasture utilisation. But it's also easier to make easier to adjust if mistakes are made in terms of feeding. Now, so a farm allocation for a typical three-way grazing system looks like this. You've got your A block, which is your morning, the first break of the day, and requires roughly 40% of the milking platform or allocation of the cow's needs. Your B block, 40% of the milking platform, and your C block. So this is the nighttime block, which is usually closest to the shed, and 20% of the milking platform. Now your A block is usually your furthest distance travelled on farm. Now we'll move on to the gate times and the natural stimuli. So these include your sunrise, the gate times, and fetching cows or farm's activity. So the cows are very smart creatures and they still recognise the sunrise as it's their time to move. Then you've got the gate times, which they will learn throughout the system, and every farm will adjust according to what suits their routines. And then lastly, you've got the farm activity. So a farmer getting on his motorbike and going around the farm promotes cows to move. Now we've got a nice diagram here which shows a simplistic version of how a cow may move through the system. The cow enters through to the pre-milking area to be milked, and then is milked through the Lely estrinault. After a successful milking, she will proceed to the post-milking area, where she'll exit the Lely grazeway. Now the Lely grazeway will separate her according to where she needs to go. So if she's on a separation for some reason, such as insemination, needs a health treatment, or simply has just been on a routing task as she needs to be monitored or be put close by. And then the other three directions will be according to what day of time it is and where she's required to go. For example, if it's 11 a.m, she may be required to go to Pasture 2 or B block, which is the middle paddock of the day. And this is how she moves throughout the system throughout the day. Now another nice example is a grazeway and positioning. So here we see the cow's going to exit and she'll either go to paddock A, B or C. Now we see here a nice flow and no 90-degree turns that the cow has to complete to exit the shed. Now, movement. Monitoring movement can be important to do to make improvements we need to be for the best possible cow movement. Monitoring movement includes looking on T4C, so Time for Cows computer program, and we look on what we call the collect cow list, which usually indicates cows that have been away for typically 14 plus hours. Another indication of in cow movement is cows queuing, especially in the morning, that can indicate a nighttime movement, and we need to come up with solutions on how to fix this. We aim for milkings to be evenly distributed over 24 hours, as we see here in this graph. This is a really nice graph. The only slump we see is around 2 to 4 a.m. period, and this may be for numerous reasons. Now the 4 different lines indicate the 4 different robots on this particular farm. Robot 1, 2, 3 and 4. But here we see even at midnight we're roughly about 4.5 milkings to 5 milkings during that time on each robot. So that's still roughly 20 cows getting milked. And even in the lower periods, still 3, which is really great. And this is what we like to see. Now this graph enables us to look at where the slumps are and how we may be able to improve if there is low free time on a farm. Grazing with robots. Now, cows move freely throughout the system, choosing when they want to come up to the shed and seek fresh pasture before they visit the fresh pasture cows are commonly due for milking. So there's less time wasted standing on yards and less pressure on their feet. We've seen farms significantly reduce lameness within their herd as cows aren't being pushed up as one big group in long races, they're not being bullied. There's also less time wasted waiting for milking, which subsequently creates more time for resting, grazing and drinking, which ultimately means producing milk. So, some top tips. 1. Ensure a good infrastructure for the cows. Cow tracks must be wide, well maintained, and always accessible when the cows are in the paddock. We want to prevent narrow points throughout the farm where dominant cows can stop and restrict the access of submissive cows. 2. Full access to water in the paddocks with water troughs close to the gateways to encourage cow flow. If the troughs are at the opposite end of the paddock, cows are less likely to walk to drink, and we know how important water is to them. So depending on the temperature and humidity, this can affect how much they drink. A cow needs roughly 3 litres of water to produce 1 litre of milk. And then, 3. Larger paddocks, backfencing is an option to prevent premature grazing affecting crop regrowth. But also consider a resodding program to ensure good sward quality across the platform throughout the grazing seasons and prevent old lays becoming less palatable. 4. Cows are more inclined to travel during daylight hours, therefore keep cows close to the shed at night and let them travel further distances during the day, in particular in the morning paddock. Keep the distance between grazing and in the shed no further than 1.5 to 2 km where possible. 5. Be flexible to accommodate changes in the weather, such as heavy rainfall, high temperatures. For example, if you've got an indoor area, this can be incorporated, and giving them shade in those high temperatures. Now I'm going to hand it over to Innocent, who will now discuss the pasture growth curve. Thank you for your time.
Thank you very much, Brian. I'm going to talk about principles of feeding cows, when you can harvest and conserve forage, and when you can feed this conserved forage back into your system. The blue line graph here is an example of a lactation curve of a spring calving head with a peak in spring, and the orange line graph is a typical pasture growth curve in most temperate regions. If you are in an area or a region where you cannot grow pasture in most times of the year, please do not feel left out, because we have options for you and we are happy to discuss these options with you. If conditions are favorable and you are able to apply nitrogen fertilizer in winter, your pasture growth curve will shift to the left to this yellow dotted line here. And this means you have early feed, which you can turn into milk, and it helps you to minimize the amount of supplements you are going to feed your cows when they calve. Thus, there's an opportunity to use nitrogen fertilizer as a supplement. You can find information about strategic nitrogen application for the best response in winter and spring on Dairy Australia website if you are here in Australia, or Dairy NZ website if you are in New Zealand. Depending on your system, the key is to have all or most of cows in by spring growth. For example, if we have a spring calving head, aim to calve your cows maybe 50 days before balance date. By balance date, I mean the estimated day when the rate of pasture growth will meet your head demand. For example, this point here on my graph, you might be 2 or 3 months off this graph. It doesn't matter. I'm talking about principles here, and principles are the same. And during peak pasture growth, surplus pasture can be harvested if identified. Otherwise, you'll be wasting the cheapest feed source on your farm. Why spend money on nitrogen fertilizer when you're not going to utilize the pasture? It does cost about as much to grow pasture and waste it as it does to grow and utilize it. But remember, in pasture-based systems, Success is closely linked to pasture utilization. Therefore, there's a need to establish a feed wage ahead of you with the potential to foresee a surplus of pasture and converting this surplus pasture at its highest quality into a conserved forage which you can feed later during the year. As the pasture starts to lignify, its quality is greatly reduced, and it's mainly for gut fuel, and it will not be meeting the energy demand of your cows. It is advisable to top for quality at this point. And whenever a feed gap is identified, for example, this point here on my graph, where your feed demand is above the feed supply, and this feed gap, it needs to be filled with high quality forage. And this is an example where you feed the conserved forage you have harvested during spring. And in some farms during summer, pasture availability and quality are the most limiting factors. And in other farms, wet winter floods do not support cows on paddocks. And this has got its own challenges, but you can overcome some of these challenges by feeding your cows high quality conserved forages. Now I'm going to explain how you can maximize ryegrass pasture performance by using 3-leaf stage. This is an example of a dairy farm with 20 paddocks from paddock 1 to paddock 20. And the first 3 paddocks are the freshly grazed paddocks with very little to no leaf remaining. And from paddock 1 to paddock 12, there will be slow pasture growth due to limited leaf area. And from paddock 14 to paddock 20, there will be a rapid growth rate due to adequate leaf area for photosynthesis. The leaf stage helps to identify when a paddock is ready to be grazed. And the optimum time to graze ryegrass pastures is between the second and the third leaf stage. So, for example, on this farm, from paddock 14 to paddock 20, these paddocks are ready to be grazed. Leaf stage is also a good indicator of how well the rotation length fits with the current pasture growth conditions. And the rotation length need to be longer enough so that the freshly grazed paddocks grows back to 3-leaf stage. And on this farm, it will be about 21 days in spring, and it might triple during winter depending on the weather conditions. Increasing the rotation length beyond the 3-leaf stage results in pasture wastage. Why? Because as the 4th leaf starts to appear, the 3rd leaf will die, and this dead material will reduce your pasture quality. And fast rotations, where you constantly graze these paddocks before the 2nd leaf stage of regrowth, will significantly reduce pasture growth and yield. So the key is to avoid back grazing these paddocks for longer than 3 days. That is the reason why Briar is indicated that you need to aim for a maximum of 3 grazings per paddock, because if you constantly graze these paddocks, your cows are eating the pasture before the energy in its root system is replenished. And also, the root system becomes shallow with consistent back grazing. But remember, you need a good root system to feed your leaves. That's how you are going to grow more grass, by plants capturing more sunlight and by having a stronger stem and root system. This is an example of a 3-leaf stage. But remember, I've said 3-leaf stage only tells you when the paddock is ready to be grazed. It doesn't tell you how much is in that paddock or where to put a break fence. Therefore, in order to accurately allocate your cow's pasture, you need to use the 3-leaf stage in combination with yield measurements, and you also need to consider the pasture quality and feed demand information. So, what are the other advantages of accurately allocating your cow's pasture? I know Briar has already highlighted some of these points. Firstly, it does improve pasture utilization. And secondly, it helps you to better match your pasture with supplements. For example, your yield measurements will tell you the quantity of pasture in that paddock, and it tells you if there are any deficits which need to be filled with supplement. And when you consider your pasture quality information, you can identify the most limiting nutrient in that pasture, and you can balance it with the right supplement. And thirdly, accurately allocating your cow's pasture improves cow movement in AMS. For example, if you do under allocate your cow's pasture, they are going to leave that paddock early. And if you over allocate your cow's pasture, they are going to be reluctant to leave that paddock. And that means you are going to collect those cows yourself. And that's more work for you and for your staff. And I don't think you will enjoy it. But there are some simple management strategies which you can use to check or to see if you are over allocating your cow's pasture or you are under allocating your cow's pasture. For example, monitoring post grazing residuals following a morning, afternoon, and night allocation of pasture, and modifying break width is a useful management tool you can use. And to summarize this presentation, most of our customers use ABC grazing system. Why? Because it promotes higher milk output per robot, also promotes even cow flow throughout 24 hours, and it is an advantage for low-ranked cows and heifers because they can choose a time when it's a bit quieter on the robot, and after being milked, they have a chance to go to a fresh break of pasture. And by acting on the information from your regular farm works, this will help you to take out the guess from decision making. And my last point here is just a tip. It is well documented that below optimum feed efficiency is the key affecting profitability in most pasture-based dairy farms. So you need to manage the pasture to cost effectively feed your cows better. And I'll end this presentation by briefly explaining some of our roles as FMS advisors. Firstly, we are involved during farm setups. We do help with paddock setup, and we also do farm works. For example, we look at your laneways to see if they need any modifications or not. And secondly, we are actively involved during startup by helping your cows and your staff transition to robots and pasture or forage. And thirdly, we do regular visits, but I want to be clear here. We do not tell you how to farm, but we help you to achieve your goals by suggesting some management solutions and also knowledge sharing. And lastly, we do respond to calls and emails, and we can also support you online using TeamViewer. This brings me to the end of this presentation. If you require any further information or if you have any questions, please email us on Lely, AUS at lely.com. Thank you for watching. Brian and I sincerely appreciate your time today, and we are happy to visit your farm and provide you a free consultation on your farm layout and do a farm walk with you. If you are interested, please send us an email on this listed email address. Our next webinar will be available to watch on the 5th of January 2021, and I'll be hosting a guest, Ian Sawyer. Ian is an experienced ruminant nutritionist, and we will be discussing about optimizing AMS by getting the fundamentals right. Again, thank you for your time today, and we are looking forward to seeing you during our next webinar.